Now let's talk about something called a homotopy type. So homotopy type. Let's say you have two topological spaces X and Y. They are called the same homotopy type, and it's denoted by X homotopic to Y if there exists continuous continuous map F from X to Y and G from Y to X such that the combination of F of G gives you the identity on Y and the combination of G of X gives you an identity on X. This is how we define the homotopy type, and the map F is called homotopy equivalence, and G is called the homotopic inverse of F. Now again, another remark regarding the homotopy type thing. If X is homeomorphic, to Y, then it's always true that X and Y are of the same homotopy type. However, the converse is not necessarily true. And the converse means that if X and Y are two topological spaces and they are of the same homotopy type, then it doesn't mean that they have to be homeomorphic to each other. Okay? And now, since we are talking about fundamental groups and we also saw some relevant definitions to it, we also proved an important theorem. Let me give you another important piece of information about fundamental groups. That is, the fundamental groups are topological invariants. That means that under homeomorphism they stay the same. Also, if two spaces have the same homotopy type, then their fundamental groups are the same. And since we have talked some definitions and all that, we actually want to see how can we actually compute the fundamental groups. Well, computing fundamental groups is not an easy task, as it turns out. However, we'll see some simple examples for now. And before we jump into examples, we just need to know two more definitions, because we have been talking about this continuous family of continuous deformations, and now we want to make it formal. So far what we have done is that we have given you some intuitive ideas, but now we want to make it formal and translate our intuitive ideas into a mathematical language, and that is done via the deformation rate tract. Now we will formally introduce that to you.